Welcome to Beyond Chips, the ECSEL JU podcast where we explore people, projects, and partnerships shaping Europe's semiconductor future. I'm Luciano Gaudio, Head of Communication at CHIPS Joint Undertaking.
And I'm Vasily Paglidou from the Communications team. Together, we'll be your hosts as we speak with researchers, innovators, and industry leaders behind the technologies powering Europe's digital and green transition.
In every episode, we'll go behind the scene of ECSEL JU founded projects. We'll hear stories of collaboration, innovation, and real-world impact, from lab to the fab and practical application.
Whether you're part of the CHIPS JU community or just curious about how semiconductors are quietly transforming everything around us, from farming to mobility, you're in the right place.
Our conversations are guided by a shared principle: clear, respectful, and inclusive communication, just like how we work every day here at the CHIPS Joint Undertaking.
So let's get started and meet the people behind Europe's chip-powered future.
Today, we are speaking with a representative from CHARM, Marco Ezendam, a project focused on bringing reliability and sustainability to harsh environment electronics. In a world where semiconductors power everything from electric vehicles to satellites, CHARM is pushing the boundaries of what's possible in extreme conditions. We are here to learn how they are translating frontier research into real-world industrial impact.
Marco, can you please briefly introduce CHARM and its main objective?
Yes, what Luciano also already said, it was for developing of sensors in harsh environments. That was the purpose of the project, and trying to see how we can do that and how we can test that, and that all in a virtual environment, so also in a digital environment.
And how do your technologies support sustainability in industries like automotive or aerospace?
From my personal view, from Raiden, what we do as a company, we do modeling and simulation. So in other words, you could also say that as virtual testing, so not real testing, but computer testing. That helps, of course, by making less prototypes. So you can, what you design and how it will work, you can already calculate that, and that will bring you results in a preliminary phase. So you don't have to test it by making real prototypes. And that helps, of course, the environment because less energy consumption and less waste. So it's a very lean method to say.
Marco, what makes CHARM unique compared to other semiconductor projects in Europe?
Of course, every project is unique, so it's all unique projects. So the question is, why is it more unique than all the other projects? But I think it was a nice mix of also companies who are not so familiar with CHIPS JU or the predecessor from it, ECSEL. For them, it's not so easy to do such a project, and that makes it nice. So it's industries who build big machines and work in harsh environments. Normally, they do a lot of trial and error in their development, and now they use completely new techniques. So the digitalization comes to them, and I think that's very nice and makes it very unique.
And how do you envision CHARM's outcomes being adopted by the industry in the long term? Because also talking about sustainability and the digital aspect that CHARM brings, it's the future in a way.
Now, I think it helps them a lot because they have seen what digitization can bring to them and can help them in the complete process from development till testing. And what we have seen, of course, we are not in the R&D departments of all the partners in the project, but I think they learn a lot of it and now are using it in their own R&D environments. So that will help the environment by the reasons I just gave. So they test less and test more digital. And in the end, they can make better products for that. So I think it helps not only them a lot, but also us a lot. As already a modeling and simulation partner and a digital active partner, we also enhanced our products and make them better and more fit for purpose.
Marco, and according to you, what role did the CHIPS JU funding play in enabling this work?
That's an open door, of course, because it speeds up development. Because, of course, you do your development and you have a roadmap that you want to fulfill. But by having nice partners and also big industry as partners, you can match what you want and what you want to do to what their needs are. So normally, as an SME or a startup or small companies, you push your technology. But pushing is not always the right way. You need push and pull. So you also need to know what your customers need. And by cooperating in such projects, you speak to a potential customer and you speak to people who do development and they give you feedback on your product. And that's very good. And because of the project, you can speed up your own development. It helps a lot in that sense.
And Marco, which technology readiness level did you have when you submitted your proposal?
It was not a research really, so it's more than that, but not industrial yet. So I think it started with 3 or 4 TRL, and in the end, I think we ran to 6, maybe 7 for some parts of the product, because of course, you want always more than that you can do in such project. But for some parts, we could realize something we could show in a demo to industry, and that's important.
And how did your consortium work together across countries or sectors? Because collaboration is always a big part of JIPS JU, especially when you're dealing with such a large project.
Yeah, that is not so easy to cooperate together. That's always, it starts somewhere, and in the end you think, oh, it's a pity that it ends, because then you know the other partners. So we had some nice cooperation, of course, with the use case we were in. That was very good. And there was a lot of meetings and things we did together. But there was also some things we didn't foresee at the beginning of the project. So we worked with an Italian partner and a Swiss partner on particle contamination. That was not foreseen, but very nice. There was a good cooperation. And we had a good cooperation with Basi from Austria. That wasn't foreseen either on sensor molding. Also very important, and a topic that was important in the project where we met them and did something together. So that it was in that sense quite good.
Marco, we always wanted to involve other potential beneficiaries in our program. So it's important also to understand some maybe lesson learned also from you. So what advice would you give to similar projects applying for future funding?
What's important for a company to participate is that you have your own R&D agenda. That's very important. So you have to know what's your dot on the horizon, where you are heading for in technology development and what's important for you. And that makes you an attractive partner for others because you can see how that fits to the complete program. And then you can develop things that are important for you, but also that are important for others. Without an R&D agenda, you are a ship on the ocean, but not knowing where to go. And then it's difficult to do something in such a big project. So, I think that's the catch up of being partner in such a project. Have an own R&D agenda.
And is there a specific moment during the course of the project that really stood out to you?
I don't think we had that moments, but we had some nice results on the sensor. In the use case we have been predicting things like wrinkling of ink, and that was not easy, and we succeeded in doing so. So that was very nice. Yeah, then we will keep that in mind.
A win is a win.
Yes.
Marco, the positive ambition is always a driving force for project ourselves in the future. So what's next after CHARM, according to you?
We have just submitted a new one in the JU Chips portal. So, and that's also on digitization, but in this case, just building digital twins for making chips. And we had some partnership with Basi Austria. And in this program, Basi Austria is also, again, one of the partners with whom we want to cooperate. So in this case, we're going to look for contamination. That's a topic we slightly addressed in CHARM, but what I said slightly, we did it for Turnos. That was a Swiss company. And it has to do with where are particles going in a system. So if you make very small systems, then every particle that shouldn't be there frustrates the functioning of your system. So you don't want to be it there. So how to prevent that is, of course, not so easy. So what we are going to do is model where particles are moving in vacuum systems, but also in production processes which are under vacuum circumstances, so that we can build better production with less faults in it. Modeling that is quite a challenge because the software that's already on the market cannot do that. You have to combine different techniques, and that's what we are going to do.
What will be the practical use of the results of CHARM projects? What will be for the positive, let's say, impact on the common user or client after that?
Now, if we have to look at our own products, so what we make as a simulation company, the outcome is a product that's called Reefs. And that's a software product which we can optimize on design parameters. So if you design a product, then you always have a lot of design parameters, and to make the right choices in that is not so easy. Of course, there's a certain performance of such a product, and you want to bring the performance of that product in relation to your design parameters. And to do that, we use Reefs, and that's the software tool we built. And what we want to do is optimize things. So optimized parameters give a certain result. In CHARM, we made a start with that. We did that. We built something. It's also called Pareto front optimization, and we tested it there, and that we are going to improve. But in the current version, it can already be done. So we are now building a product that comes to the market within half a year, where it will be in there. And then customers who use that can use the techniques developed in CHARM.
You gave us really a lot of information here, Marco, so thank you very much. And also good luck with your new proposal.
Thank you very much again, Marco.
Yes.